The next focus of these lectures will be the citrate test. Now, in order to test for that ability, in order to test to see if an organism can use citrate as its own carbon source, we use Simmons citrate agar. Now, this is a defined media. Every component is measured out to the gram. And that means even the carbon source is measured to the gram. There are no extracts. So the carbon source in this media is sodium citrate. We also have a nitrogen source. Now you may say to yourself, well, why do we need nitrogen? Well, nitrogen is very important in a cell building its proteins. It's important in the cell building its nucleic acids. So the nitrogen source in Simmons citrate agar is ammonium phosphate. Now that's going to become very important, especially that ammonium part, right? So bacteria that have the ability to use citrate as the sole carbon source also have the ability to convert that ammonium phosphate to ammonia, NH3. Now, as we've learned previously, is ammonia an acid or a base? That's right. Ammonia is a base. Therefore, if an organism is using citrate as the sole carbon source, the media is going to turn alkaline or basic because in addition to using citrate, it's also using the ammonium phosphate. So we can look at changes in pH as an indication of citrate utilization. Here's the control tube. That is what the tube looks like before organisms were added, before it was inoculated. We see it's a nice green color. If your organism can use citrate as its sole carbon source, the Simmons citrate agar is going to turn blue. And it turns blue because of those alkaline or basic conditions. Now, why is it turned basic? As we just talked about. As we use citrate, ammonia is also produced, and ammonia is also a base that's going to turn the medium alkaline. Now, why use this Simmons citrate agar? What's the application? Well, first, it allows us to determine if an organism can use citrate as its sole carbon source. And that's a unique ability amongst some of the enterics. So the first application is it allows us to distinguish amongst the enterics from other gram-negative rods. We can also differentiate amongst the enterics themselves. Some of the enterics can use citrate as its sole carbon source, others cannot. All right, let's test ourselves for that practical then. What is the interpretation of the organism on the right? Here's your control tube. Here's where we added our unknown organism. What is the interpretation? That is correct. The organism was not able to use citrate as its sole carbon source. Therefore, the pH of the media did not change. So in this case, citrate is not utilized as a sole carbon source. Well, now this is easy, right? Let's go on to the next one. What is the interpretation of the organism growing in that citrate slant? Here's our control. That's right. We can see that the tube has turned blue, an indication of alkaline conditions. And those alkaline conditions tell me that citrate was utilized as a sole carbon source. As that citrate's being utilized, the ammonium phosphate is also being catabolized to produce ammonia, and it's that ammonia that produces those alkaline conditions.